Okay, so here is the Edexcel GCSE Maths Paper 1 from summer 2017. So we're going to go through a few of the first questions. Let's start off with question 1. So question 1, we have a scatter graph. And whenever you see a scatter graph, before you start reading the questions, the best thing to do is to draw on your line of best fit. Scatter graph, remembering, is we've got different points and they do not form a specific equation here. So I'm going to go ahead and draw on a line of best fit. You make sure that when you're doing this that you're using a ruler so it's perfectly straight, scatter graph, and make sure that you've got a very similar number of points on either side. As you can see, mine's probably a little bit low, but I haven't got a ruler. So now we've done that, let's have a look at the question. One of the points is an outlier. Write down the coordinates of this point. So if we have a look at our points, a lot of them are reasonably close to our line of best fit, but there is one over here that is a long way off. So this is our outlier, and we can read off the coordinates. That will be 10, 19. And there's the one mark. So going on to B, for all the other points, write down the type of correlation. Now there are sort of three main correlation we'll expect. So we can have where all of the points form a line like this, where they're negative correlation. We can have sort of points scattered all over. And here you can't really see a nice neat line of best fit, so we're going to have no correlation. And then finally, all our points angled up from the bottom left to the top right, and that's going to be our positive correlation. So for this one, we have positive correlation as a mark. Okay, so going on to question C. On the same day in another town, the maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine in this town on this day. So this is where our line of best fit comes in. So as we've already drawn our line of best fit, it's nice and easy. We can have a look, find 16.4 degrees, which is about there. Oops. Go across to your line of best fit and then down, take the reading. Now this question allows a little bit of flexibility of answers. The main point on the mark scheme is that the examiners are allowed to use flexibility depending on the line of best fit. So you need to make sure that your answer fits the line of best fit. So for me, that gives me 13 hours of sunshine on this day. Finally, let's move on to part D. A weatherman says temperatures are higher on days when there's more sunshine. Does the scatter graph support what the weatherman says and give a reason? Okay, so I'm going to answer this up here. Having a look at the data that we have, when we have low number of hours of sunshine, we have low temperatures, and as the number of hours of sunshine increases, the maximum temperature increases as well as we head up sort of that way. So for D, I would answer yes. As for low, let's put numbers of hours of sun, max temp is low and increases as number of hours of sun increases. Now I expect you can probably write that a little bit more succinctly, but that would give you all the marks for that question. So we're now going to have a look at question 2. And we've been asked here to express 56 as the product of its prime factors. So key fact here, prime factors, and we want to express it as a product here. So let's start with 56. And I always start with 2. Knowing that 56 is even, we can divide it by 2 nice and easily to give us 28. Again, we can have 2, give us 14, 2 again to give us 7, and 7 is prime. So now all we have to do is have a look at our prime factors. So we can say that 56 is equal to 2 times 2 times 2 times by 7. And that there is your 2 marks. Moving on to question 3. We want to work out 54.6 times by 4.3. Knowing that this paper is non-calculator, we can't just type it into a calculator. So my method, and there's many different methods you can use to do this, is Napier's bone, sometimes called a grid method or another name. So we have our grid lines in, and we're going to write 54.6 here and 4.3. So just multiply across. So we've got 5 times by 4 is 20, 4 times 4 is 16, 6 times 4 is 24, 6 3s are 18, 4 3s are 12, and 5 3s are 15. Now we simply add, going down the diagonals. So for this diagonal here we have 8. Next one we have 4 plus 1 plus 2 is 7. Then we have 6 plus 5 is 11, plus 1 plus 2 is 14. Got a 1 up here. Then we have 1 plus 1, and not forgetting that one, so that's 3 and 2. So now we have to look at our decimal places. It's black. So we're going to follow this one down, follow this one across, and that gets us to here. And then we just follow the diagonal. Our decimal place goes after the 4. So that tells us that 54.6 times by 4.3 is equal to 234.78. Now this is, I think this is a 2 mark question. Not sure what's going on there. Okay, that's just jumped in front. Okay, so that was 0.78. So yeah, I think it's a 2 mark question. So let's double check. If we've got, let's run this down to 50, times by 4 is 200. Our answer is around 200, so that makes perfect sense. Okay, so question 4. So here we're mixing a bit of shape with some algebra. So we've been told that the area of the square ABCD is 10 centimeters squared. And we want to show that x squared plus 6x equals 1. Now, I'm not going to worry about that last bit a minute. That hopefully will come out as we do our calculations. So the first thing I want to do is to have a think about how I'm going to find the area of this square. So we know it's 10 centimeters, we've been told that. But we've got our measurements along the sides. So the length from A to B is 3 centimeters plus x. and the length from A to D is 3 centimeters plus x. So that tells us that the area of the square, which is the base or the top times by the height, is going to be 3 plus x times by 3 plus x. And we've been told that that is equal to 10. Let's expand these brackets. So that's going to give us 9 plus 3x plus 3x plus x squared, which is equal to 10. If we just tidy that up a little, then we can say that x squared plus 6x plus 9 equals 10. And let's subtract this plus 9. So we're going to have x squared plus 6x. The plus 9 goes. 10 take away 9 is 1. And now if we have a look back at our question, we can see that we have come up with the required equation. So tick, there's our 3 marks. We've shown it, we've not used this equation. When it says show that, you need to use all of the rest of the information to get to that point. Let's move on. Okay, so question 5. We have a rectangular frame made from 5 straight pieces of metal. So we've got 1, 2, 3, 4, 5. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. So the first thing we can do, or the first thing we need to do, is find out the total length of metal that we have. So we've got, let's label the rest of our sides. 5 meters is 5 meters, 12 meters, and 12 meters. So the outside is equal to 12 plus 5 plus 12 plus 5, which gives us 34 meters. We now need to work out the length of the diagonal. So if we have a look at what we've got here, we have ourselves a right angle triangle. And as soon as you see a right angle triangle, we need to think either trig, so SOHCAHTOA, or Pythag. Now for this one we don't have any angles. We're not being asked to find an angle, we just want to find this third length, so we're going to use Pythagoras. So simply enough, a squared plus b squared equals c squared. Label up the triangle, so 12 squared plus 5 squared is c squared. 144 plus 25 c squared, so that should be 169 c squared. If we then square root both sides, that should give us 13 is equal to c. So now we know that the length of our diagonal is 13 meters. So the total metal is 34 plus 13, which is equal to 47 meters. That is an equal sign. Okay. So we now need to work out the weight. We've got how much metal? Let's work out the weight. In the question. So the weight of the metal is 1.5 kilograms per meter. So for every meter, it's 1.5 kilograms. We have 47 meters. Without a calculator, so let's say we have, I'm going to say 46 plus 1 meters, and I'm going to deal with that after. For now, the 46 meters is 46 times by 1.5, should give us 46 and 23, which is 69 kilograms, plus the extra 1.5 kilograms from this extra meter should give us 70.5 kilograms. kilograms. So the total weight of this rectangular frame is 70.5 kilograms. Going on to question 7. So now we're starting to look at some statistics, data. So we've got 10 boys and 20 girls. They have a test and the mean for the whole class is 60. The mean mark for the girls is 54. We want to find out the mean mark for the boys. So let's have a quick recap. The mean is where we add them all up and divide by number of people in this case. So in other words, the total number of marks divided by the number of people. So let's see if we can find out how many marks in total the whole class got. So if our mean is 60, and we know that there are 30 people in the class, then the total marks divided by 30 is going to be equal to 60. So multiplying both sides by 30, we can find that there were 1,800 marks in the whole class. Let's just write that in the whole class. So now let's have a look at the girls. Same thing again. Let's use a different colour. So we're going to say that there are 54 is our mean, which is equal to total marks divided by the number of girls. Now, make sure this time we're only using 20, because there are only 20 girls in the class, and before we had 30 because it was 30 students altogether. So here again, to find the total marks, we're going to multiply both sides by 20. So that is 1,080. Yep. Let's double check. So that's total marks for the girls. So if the whole class got 1,800 marks, the girls earned 1,080 of those, then we can do a quick subtraction. 1,800 minus 1,080, which gives us 720 marks from the boys. In this case, the marks the girls didn't get are the ones the boys must have got. Now, we've been asked to work out the mean for the boys. If we've got total marks, then the mean is equal to the total marks, 720, divided by the number of boys, which is 10. So they have a mean mark of 72. So mean mark for the boys is 72. And that would give you full marks. Continuing on, question 8. That's a little bit hard to see, but that is 7.97 times by 10 to the minus 6. So this is looking at standard form. We want to convert a number that's already in standard form back into sort of how you usually see them. So what does this really mean? Well, 10 to the negative 6. That means that we need to move the decimal point 6 places to the left. So if I write 7.9, further over, 7.97, we need to move this decimal place 1, 2, 3, 4, 5, 6. That's now a decimal point. We'll put zeros in these gaps. So for 8a, we have 0.000000797. Okay. And that's all it's asking. So moving on to part B, we want to work out the value of 2.52 times 10 to the 5 divided by 4 times 10 to the minus 3. So the first thing that I'm going to do is have a look at our 10 to the powers. If we've got 10 to the power of 5 divided by 10 to the power of minus 3, oops, just correct that, there we go, then that is the same as 10 to the power of 5 times by 10 to the 3, 10 cubed, because that is a negative. So that is the same. Remember, when we're multiplying, we add the powers. 5 plus 3 is 8. So now what we need to do is have a look at the rest of our fraction or our division. So we've got 2.52 divided by 4, and then that is all times by 10 to the 8. Now, dividing this by 4, let's just halve it and halve it again. Simplest method, easiest not to make mistakes. So that's going to give us 1.25, so 1.26 over 2 times by 10 to the 8, which is equal to half, so 0.63 times by 10 to the 8. But we still haven't finished. We've been told to give our answer in standard form, and this is a common place where people lose marks, because whilst it may look like it, that's not actually in standard form. We need one digit in front of the decimal place that's non-zero. So that is actually 6.3 times by 10 to the 7. Now it's in standard form, and all is good. So let's move on. Okay, question 9. Jules buys a washing machine. That's irrelevant information, we're not fussed. 20% VAT is added to the price of the washing machine. Jules then has to pay £600. What is the price before the VAT is added? So what we want to do is have £600 and subtract 20%. Sorry. We need to take off the VAT that was paid. So if we say that 120% of the price, of the original price, is equal to £600, then to find 1% of the original price, we need to divide both sides by 120, which should give us 5, I believe. 120, 240, 360, 480, 600. So 1% is £5. We want to find 100%, so nice and easily, 100% is £500. And there is the price of the washing machine with no VAT added. So just to go back, why is this 120%? If 100% is the original cost pre-VAT, so before that, we add on the 20% VAT, and that gives us the 120%, which is £600. So that is why we had 120% and then you simply have to divide by 120. And then times by 100 to get our 100%, which is the cost before that. Okay, final question in this video, question 10. We want to show that x plus 1, x plus 2, x plus 3 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b and c are all positive integers. Now, this question is an easy one to get, however, you can lose marks through silly mistakes. And a lot of people actually just leave it because it looks quite scary. But let's break it down. Let's take these first two brackets, x plus 1, x plus 2. If we expand them, then we can multiply by x plus 3 afterwards. So we can all multiply out some brackets, so x squared plus 2x plus x plus 2. And we're now going to simplify that down to x squared plus 3x plus 2. Make sure you simplify as you go, because otherwise it can get out of hand. Now, of course, as mentioned, we've only looked at two brackets, so I'm going to put our answer to multiplying out x plus 1, x plus 2 in one set of brackets, and the other one we're now going to multiply by x plus 3. So, again, x squared times x is now x cubed. X squared times 3 is 3x squared. 3x times x is 3x squared. 3x times 3 is 9x. 2 times x is 2x, and 2 times 3 is 6. Simplify this down. X cubed plus 6x squared plus 11x plus 6. And let's have a look. Is this in the form we want? It looks like it, because a is 1, b is 6, c is 11, and d is 6 as well. So brilliant, they're all positive integers, and that's good. So we've quickly gone through questions 1 to 10. Hope to do another video following on where we can do the rest of the paper. Hope you found this useful. Thank you very much.